I got a request from Mr. Naveen from Chennai. Uh, he wanted to know about trigonometric identities. I'm looking at exercise 8.4, question 5, and the first one is prove the following where angles involved are acute angles for which the expressions are defined. So the first one is cosecant theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. So there's a trick, or I should not say a trick. There's a proper way to go with these identities. So what I used to do when I was studying class 10th was convert everything to sine and cos, sine and cos, convert everything to sine and cos. That way, your expression is reduced only to sine theta and cos theta on both the sides, and you are able to easily compare and see what else needs to be done, and then you can go ahead and prove it. So in class 10th trigonometric identities, I've seen that you need to remember this, remember the basics. First, you should know that tan theta is equal to sine theta divided by cos theta. Okay, and the reciprocal of tan theta is cot theta. So cot theta is equal to 1 upon tan theta. Now tan theta is sine theta by cos theta. Sine theta by cos theta. So now this cos theta will go up. Sine theta will remain in the denominator. And here you go, this is cot theta. So tan theta is sine theta by cos theta, and cot theta is reciprocal of tan theta, so it is cos theta by sine theta. Then you also need to remember this cosecant theta is equal to 1 upon sine theta, and reciprocal of cosine of theta, that is cos theta, is secant theta or sec theta. So some people like to call it cos theta, some people like to call it cosine theta, some people call it sine theta, cosecant theta, or cosec theta, or whatever is your style. So apart from this, tan theta is sine theta by cos theta, cot theta is cos theta by sine theta, cosecant theta is 1 upon sine theta, sec theta is 1 upon cos theta. You need to remember this as well. Sine square theta plus cos square theta is equal to 1. And we can easily prove this identity using Pythagoras theorem. So because sine theta is what? It's perpendicular upon hypotenuse. Okay, and cos theta is what? Is base upon hypotenuse. So when you open the squares, you get p square by h square plus b square by h square. The LCM is only h square, so you can just add these two, p square plus b square Now what does the Pythagoras theorem say? It says perpendicular square plus base square is equal to hypotenuse square. That's Pythagoras theorem. So ninth class mathematics. So we know that. You can just substitute it over here and you get 1. So this is easily provable, and then you need to remember this identity. Then you need to remember this. Then you also have to remember this, that reciprocal of sine theta is cosec theta, reciprocal of cos theta is secant theta. Then you need to remember this, tan theta is the ratio of sine and cos, and cotangent theta or cot theta is cosine theta upon cos theta. So 1, 2, 3, 4, 5. You need to know all of these identities. Rest of them you might have seen in the book. This cosecant square theta is equal to 1 plus cot square theta. You can easily derive it from this. Let us see how we can derive it from that. So before we go on proving these identities, I just want to set a base so that you know what we are doing here. So I'm not jumping straight into the questions. We will just have a look at the identities first. So how can I prove this from this? So as we can see, we have a cotangent here and we have a cosecant here. So what we can do in this one is convert these into cosecant and cotangent. So how can I do that? We know that cot theta is cos theta by sine theta. So I have cos here and I have sine here. So what I can do is I will divide both of these equations with sine square theta. So I'm not doing magic. I'm just seeing that what do I need to prove here. I need cotangent theta in my equation, which I have to prove. So I divide this by sine square theta, but this is an equation. So if I am doing some operation on the left hand side, I have to do the same on the right hand side as well. Okay, so 1 into 1 is 1. So, but when I open this bracket, I will get this sine square theta by sine square theta plus cos square theta by sine square theta is 1 upon sine square theta. Okay, so this and this are equal, so you can just cancel it and you get 1. And you have cos square theta by sine square theta over here. So what we can do is use a little bit of math that is taught in class 9 and take the whole square outside. So this is cos square theta by sine square theta. I'll just put the square outside. Over here as well, 1 upon sine square theta, I can write this as 1 upon sine theta whole square. And we know cos by sine is cot. We just saw that up here, so I will put it over here. Cot theta whole square is cot square theta. And 1 upon sine theta is cosecant theta, so I will put that here as well. Cosecant square theta. So I have easily derived this identity, which is mentioned in the book as an important one, from this one. So it's easy. You can remember this. And I think there's another one, secant square theta is equal to 1 plus tan square theta. We can derive this one as well from this one, sine square theta plus cos square theta is equal to 1. So what do we do now? We have tangent here. So in the tangent, sine is in the numerator and cosine is on the denominator. So what I will do here is I will take this guy into the denominator. How do I do that? I will divide both sides by cosine square theta. So I will get sine square theta plus cosine square theta, but divided by cosine square theta plus cosine square theta divided by cosine square theta is equal to 1 upon cosine square theta. Now this is sine by cos. We know that this is tangent theta, and there's square on both sine and cos. So this is tangent square theta. Cos square and cos square are equal. You cancel them out, you get 1. What is 1 upon cos theta is secant theta. And since it is square, you have secant square theta. So we have proved this one as well. So it's so easy. You just have to look what do you want and from what you can get it from. So I wanted tan square here, so I thought maybe I should just divide by cos. I will get sine by cos, so that is tan. So I will get what I want. Over here I wanted cosecant square theta and cot square theta, so I divided by sine square theta because I know cos by sine is cot. So that's how I derived that one. So I think this sets up our base for moving to proving trigonometric identities. So first one was what did I mention about? Yeah, cosecant theta minus cot theta whole square is 1 minus cos theta by 1 plus cos theta. This is what we have to prove. So let us just first look at the left hand side. Left hand side is given to us as cosecant theta minus cot theta whole square. I said let us just convert everything to sine and cos. That just makes our life really easy. So cosecant theta is, we know that if the reciprocal of sine theta is 1 upon sine theta, and cos theta we know is 1 minus cos theta by sine theta. This is whole squared. As you can see, the LCM is sine theta in both of these terms. So we can write it simply as this: 1 minus cos theta by sine theta. Easy. Now we have a square on the top and on the bottom. So what I will do is I will write it at like this: 1 minus cos theta whole square by sine squared theta. So now let us look at the right hand side. What do we have here? We have converted the left hand side into sine and cos. As I said that it's very easy to just convert everything to sine and cos, both left hand side and right hand side. That makes our lives much easier, much easier. Now look at the right hand side. What do we need? 1 minus cos by 1 plus cos. I have 1 minus cos and 1 plus cos. 1 minus cos I can see here. Okay, so we are close. But I have 1 plus cos theta in the denominator. But this guy over here is sine square theta. So let us look at the right hand side. What we are given as right hand side in the identity, we are given as 1 minus cos by 1 plus cos. So there is no sine theta in the right hand side. There is no sine of sine theta. It's a bad joke, but there is no sine here. So I need to get rid of this thing as well and convert it into cos square theta. So do we know a way in which we can convert sine square theta to cos square theta? Yes, we do. Yes, we do. It's right here. Sine square theta plus cos square theta is 1. We can get rid of the sine square theta and get cos square theta. How? Just take cos square theta from here and put it there. So since sine square theta plus cos square theta is 1, I can write my left hand side, which is 1 minus cosine of theta whole squared divided by sine square theta. I will just write it as 1 minus cos square theta. So now my left hand side and my right hand side are starting to look pretty similar. Now I need to simplify this. Okay, now you just have to think, like, how the hell do I get rid of square over here? I have a square over here. It says 1 plus cos theta in the right hand side. I have to go from here to here. How do I go from here to here? You can uh, you can guess if you think hard enough. There's this identity a square minus b square is equal to a minus b into a plus b. Do I have b here, b square here? Yes, cos square. But I don't have an a square here. But we do know that 1 square is 1. So I can just write it like this. And when I write it like that, 1 square is 1. We know that 1 multiplied by 1 is 1. So I will get 1 minus cos theta whole square divided by a square minus b square. I can use this identity which we studied in class 9. A minus b into a plus b. I will just write it like this. 1 minus cos theta and 1 plus cos theta. So now our left hand side and right hand side are looking pretty close to each other. I have 1 minus cos here, I have 1 plus cos here. Only thing that I don't need is this square term and this. So this is just the square of this, 1 minus cos theta in the denominator and 1 minus cos theta whole square in the numerator. I can just, since it's a square term, I can write it like this. 1 minus cos theta into 1 minus cos theta. Easy, yeah? And I have 1 minus cos theta over here. I have 1 plus cos theta as well. I can get rid of these two. No, I'll just get 1. Now 1 times this is simply that term. So I will get 1 minus cos theta over 1 plus cos theta, which is our right hand side. Hence we have proved. Hence proved. LHS equal to RHS. LHS is left hand side is equal to RHS, which is right hand side. That's it. You'll get full marks if you just write this much. That's it. So we are done with the first problem. Now let us have a look at the second one. Second identity is prove cosine of A by 1 plus sine of A plus 1 plus sine of A divided by cos of A is equal to 2 secant A. So what I said earlier was just convert everything to sine and cos. So when we look at left hand side, it's already in sine and cos. So what I will do is I will just simply use algebra on this. I'll just simply multiply and divide this stuff. Let us look how we can do that. Cosine of A by 1 plus sine of A plus 1 plus sine of A by cosine of A. We will have to take LCM. 1 plus sine of A into cosine of A. What do we get in the numerator? 1 plus sine A is here, cos A is not, so we will get cos squared A. Cos A is here, so this will be getting multiplied to our numerator. So we have 1 plus sine A already over there. So we will get this. Now in class 9, I think there's this identity A plus B whole squared is equal to A square plus B square plus 2AB. So we will have to use that one over here. What do we get in left hand side is cosine square A. A square, A is what? A is 1. So 1 square is what? 1. B square, B is what? Sine of A. So sine of A squared is what? Sine square A. 2AB, 2 into 1 is 2 into sine A is 2 sine A. So we are done here, and let us just keep the denominator like this only for now. We will not touch it. Why do I not want to touch it? Why do I not want to open this bracket? Is because I think the numerator will look a bit easy when we go into a bit deep in it. So I have cos square a here and I have sine square a here, and there is plus sign. So cos square plus sine square is what? 1, and 1 plus 1 is what? 2. So I will get 2 plus 2 sine a. So that is why I was not wanting to touch it, because I have 2 plus 2 sine a, which is looking a bit like what I have in the denominator, which is 1 plus sine a. What will I do now? I will just take 2 common from the top. I will get what? 2 into 1 plus sine a divided by what? Cos a. And I also have 1 plus sine a over here as well. So that's it. Now this 1 plus sine a and 1 plus sine a are common. I'll just get rid of this shit. So 2 by cos a. We know that cosine of a is equal to 1 upon secant a, and secant a is 1 upon cos a. So this is what? 2 secant a, and which is what? Our right hand side. So left hand side equals right hand side, hence proved. We are done. It's not that tough. It is not tough. Now what do we have here? Look at the third one. So remember, in 10th class, if you want to prove a trigonometric identity, just put everything in terms of sine and cos, and your life will be much easier. Tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta. I mean, that's just the most basic way to solve these problems I could think of. When you become a bit of expert in it, you don't even need to convert it into sine and cos. You can simply see the easiest and the fastest way to do it. But since we are just starting with trigonometry in class 10th, let's try to keep things simple and just follow a regular algorithm, which is put everything in terms of sine and cos every time. Let's make our lives easy. Let's not overthink stuff. Let's not be a hero. So I have LHS here. Now I know that I'm going to be converting everything in sine and cos. So tan is sine upon cos. Yeah. Cot is cos upon sine. Same thing I'm going to do over here, cos upon sine. So this might start to look a bit crazy, but you don't have to be scared of it, because in the end it will just all work out. Don't be scared, is what I'm trying to say. So your left hand side will be what? Sine theta upon cos theta into sine theta minus cos theta, and you have sine theta over here. It will go up. You will get this. And since it is 1 minus cos by sine, so when I take the LCM, it will become sine minus cos. So that is why I'm getting this expression. So I hope you understand this. So cos theta by sine theta, and over here what will you get? Cos theta minus sine theta, and since cos is over here, I can take it up, so it will become cos into cos, which is cos squared. So I'm seeing this commonality over here and here. This is sine minus cos, and this is cos minus sine. So if I take the minus sign out, I'll get this, cos theta into sine theta minus cos theta. I'll take the negative sign out. I will get cosine square theta by sine theta into sine theta minus cosine theta. Now what will be my LCM? I want to simplify this expression. It will be sine theta cos theta sine theta minus cos theta. If this is looking a bit overwhelming, don't worry about it. As I said, it will all work out. So I have cos theta into sine theta minus cos theta here. So what will be remaining that I have to multiply my numerator with? Sine theta. I already have sine square up. So what will I get? I get sine cube. Similarly, I have sine minus cos, only cos is remaining. So cos theta will be multiplied with cos square theta. So cos square theta times cos theta will become cos cube theta. Now this is looking a bit crazy, but this looks like it has something to do in commonality with this. Now we do remember that a cube minus b cube is a minus b into a square plus b square plus ab. That is, I think, another one from class 9. So I can just get rid of my cubes here and get this. And when I get this, I know that sine minus cos is already there in the denominator, so I can get rid of this term over here. So my LHS will become sine theta minus cos theta. What is A? A is sine, so sine square theta. B is cos, so cos square theta. AB, so sine theta cos theta. This is all in the numerator. In the denominator, I have this term sine theta cos theta into sine theta minus cos theta. I'll get rid of this. Now what do I have here? Sine square plus cos square. We know that sine square plus cos square is 1. So I'll put that over here. 1 plus sine theta cos theta. Now this is divided by sine theta cos theta, sine theta cos theta. If I look at the right hand side, I have 1 plus secant theta cosecant theta. Remember I told you we can convert everything to sine and cos and make our lives much easier. 1 plus secant theta cosecant theta. This is what we are provided. So I'll just get rid of the secant. I will put it in terms of sine and cos. Secant we know is the reciprocal of cos. Cosecant we know is the reciprocal of sine. So we have 1 by 1 plus cos theta sine theta, or sine theta cos theta is the same way. It means the same. Take the LCM. You get 1 plus sine theta cos theta by sine theta cos theta. So isn't my RHS looking the same as LHS? Yes, it's exactly the same, hence LHS equals RHS, hence proved. Hence proved. Now let us look at part 4. So I hope that you guys are starting to get a hang of these trigonometric identities. 1 plus secant A by secant A. So you can write A, you can write theta, you can write beta, you can write gamma, whatever the hell you want, but it won't change anything. So don't be confused by the use of these angles, which is theta or A or B. 1 plus secant A by secant A is equal to sine square A by 1 minus cos A. Remember what I said, just change everything to sine and cos, make your lives easy. 1 plus secant of A by secant of A. When you put secant as 1 upon cos, and when you simplify this, what will you get? You will just get this 1 plus cos A. Simply easy. LH is only 1 plus cos A. There's nothing in this except 1 and cos. But on the right hand side, I have sine as well as cosine. Right hand side is 1 minus sine square A upon 1 minus cos A. We know that we can get rid of sine. We can easily convert it into cosine. On the left hand side of the equation, we only have cos, no sine. So we get rid of this sine. How do we get rid of sine square A? We know that sine square A plus cos square A is 1. So sine square A is 1 minus cos squared A. So we have got rid of the sine completely, and right hand side is only, it's 1 minus cos A. 1 minus cos A. But it's 1 plus cos A here, and over here we have 1 minus cos square A and 1 minus cos A. So why don't we use this again? A square minus B square is A minus B into A plus B. I'll just write 1 as 1 square again. Remember that you will have to use A square minus B square is A minus B into A plus B a lot in these trigonometric identities, a lot many times. A minus B will be what? 1 minus cos A, and A plus B will be what? 1 plus cos A, and it was divided by 1 minus cos A. Oh, we can easily get rid of this. What are we left with? 1 plus cos A. And what did we have in the left hand side? 1 plus cos A. So left hand side equals right hand side. Hence proved. Okay, so we have done like 4 parts already. There are 6 more remaining. I think I will cover them next time because it's getting really late. Okay, so goodbye.